Hello everyone, my name is Ariel. I'm handling pre-sales and product management for GeoQlik. GeoQlik is an extension for Qlik Sense and Qlik View that brings some powerful geospatial analysis capabilities inside your dashboards. In this session, I will demonstrate how GeoQlik can be used to measure the impact of weather on a business. There are several examples of somewhat unpredictable factors that can deeply impact our business. One example can be the financial environment. None of us can really predict a financial crisis. The one in 2008 was a good example of that. A sudden drop of stock markets isn't something we can foresee, at least not most of us. Another example can be fashion trends. While the biggest fashion houses fight to determine next year's trends, a retailer can't really know how much inventory to prepare, or as they say in the fashion industry, what's hot today could be tomorrow's old news. Weather is our topic today, so let's focus on that. With the weather, we have long-term forecasts and short-term forecasts. The long-term forecasts are, of course, much less precise. They are vague estimates. On the other hand, short-term forecasts are more accurate and update very often. Let's now focus on a company called Fresh and Ready. This demonstration is based on an actual use case we've encountered, but the data and the figures you'll see here today were simplified for the purpose of this demonstration. This company specializes in providing ready meals. Their products are always fresh, which implies a supply chain with a short cycle time. More about this later. This company targets mainly the outdoors market, providing picnickers with top-notch fresh products. As you can imagine, consumption depends a lot on the weather. As most normal people don't enjoy a picnic when it rains, there's a sudden drop in demand when and where the weather is bad. As we supply mostly to supermarkets, the risk is to either supply too much, which generates waste, or to not supply enough, which means losing business. In both cases, we're losing money, and in both cases, supermarkets tend to negotiate prices. If they see that they sometimes end up throwing out 10% of what they bought, they will try to lower the prices they pay. The question that arises is therefore, can we do better in predicting the demand based on weather forecasts? Before I move to the live demonstration, let's take a look at Fresh and Ready's supply chain. We'll keep it simple for the sake of the demonstration. The first element that will be of interest to us is the suppliers. They typically receive the raw material from local farmers. The suppliers then deliver the raw material to factories that can take a couple of days, marked in T1. The factories then need some time to prepare the products. Again, could be a couple of days, marked with T2. The products are then delivered to the different supermarkets. What we're going to see here today is how a 7-day weather forecast model can be used. We'll focus on our supply chain and mainly on the part framed in gray, the suppliers, the factories, and the stores. The idea is going to be to better predict the demand of the stores, which means that by knowing how much the stores actually need 7 days in advance, we will adjust the volumes we need to produce. Therefore, our supply chain needs to have a cycle time of maximum 7 days. 7 days from the time we place an order with the supplier till the moment we put the products on the shelves. A few words about the demonstration you're about to see. We'll start the demonstration with analyzing our supply chain. This will help us determine how compatible it is with a 7-day forecast model. In other words, whether the cycle times are not longer than 7 days. Then, we'll look at an example of a single supplier and try to understand why he has difficulties with delivery times. Next thing we'll look at will be raw weather data, as can be found on the server of the NOAA, National Oceanic and Atmospheric Administration. We'll use GeoQlik to see an animation of 1 month of precipitation forecasts. The next step will be to view the same data, but this time transformed into usable business indicators on our business territory. We'll then continue with applying the weather model on our supply chain in order to better determine customer demand and apply it on the volumes we produce. And we'll finish with a global yearly summary of the savings obtained in 2016. As you can see, the one thing all these topics have in common is the spatial dimension that we're going to master using GeoQlik. I'm now going to switch to my Qlik Sense app. This first sheet will allow me to analyze my supply chain. The purpose again is to verify that a full cycle doesn't take more than 7 days in my existing supply chain. And so the map you see here, right now taking most of the space in the sheet, is GeoQlik. I will start with displaying the map contents panel, which lists all the layers that are currently configured for this map. For the purpose of this demonstration, we will focus only on the southern states of the US. Let's start with displaying the different components of our supply chain. So starting with the suppliers, marked with blue stars, the factories, and the different stores. Let's maybe zoom in slightly. And now let's see how all these elements are linked together, starting with the links between the suppliers and the factories, and then between the factories and the different stores. What we see here now gives us an overview of our entire supply chain. However, it still doesn't help me answer whether it satisfies the 7-day requirement. By activating the analysis using the On button, GeoQlik now highlights all the segments that are part of a cycle that takes more than 7 days, marked in red. In green, all the segments that are okay. Now this takes me a step further. I can already see that in most cases we're fine, but in some others, we have a problem. The next step, using the button below, greater than 7 days, will be to filter out the green segments so I can better analyze the red ones. So now we're left only with the cycles taking more than 7 days. Let's examine the results. As you can see, on top of the suppliers, factories, and stores, we've also placed labels. GeoQlik allows you to place text on the map using expressions. Each label now describes the amount of time necessary at each stop with the total cycle time given on the stores. So naturally, all the cycle times we see right now are of 8 days and more. For example, if we take this supplier here, we see that this particular supplier needs 2 days to deliver the raw material to the factory, which then needs 3 days in order to manufacture the products. So when the products are ready, we are already at day 5, and then 3 more days to deliver the products to 2 different shops. And so the total cycle time here is 8 days. In addition, the tooltips generated by GeoQlik can help get much more information when hovering above. So either over the stores, over the factories, or over the suppliers. This allows us to get a lot more information and figures for the different elements. Let's look at a specific case and try to analyze what's happening here. So with this particular supplier, we see that the main problem is that it takes him 5 days to deliver the raw material to the factory. Now that's definitely a problem if I want to limit my cycle time to 7 days. Let's try to understand what's happening with this particular supplier. So I'm going to switch to the next sheet, which allows me to drill down to the sub-supplier level. The sub-supplier is a level of detail we didn't present in the previous sheet. Sub-suppliers in this case are probably local farmers. And so I'm going to start with selecting on the map the supplier that I want to analyze. So clicking on the map and applying. GeoQlik now drills down to the sub-supplier level and zooms the map. So what we see now are the different local farmers that deliver the products, the raw material, to this particular supplier. The width of the lines shows me the volume each one of them can deliver every week. And the color shows me a different indicator which describes the level of reliability of this farmer. As this supplier had some problems in the past, he decided to rate the reliability of each one of them. Now, the products delivered to this supplier are super fresh. In fact, according to regulations, this raw material can't travel for more than 1 hour without using a refrigerated truck. A refrigerated truck is something not all of these farmers can afford, which means that the supplier sometimes needs to handle the deliveries. Let's try to evaluate the implications of this on our business. Again, 1 hour travel time maximum for the raw material. Using the isochrone tool integrated in GeoQlik, I can see how actual driving times can impact my business. So I'm going to use this tool to plot the area corresponding to 1 hour. And so typing 60 minutes in 3 steps and clicking the supplier. What I see now is the area reachable in 1 hour drive. GeoQlik just calculated all the possible routes from this location, the supplier, traveling for 1 hour in all possible directions. By the way, notice that the shape is slightly elongated. That's because of the road passing right in the center, which means that I can travel farther going northeast or southwest. What I can do now is filter my selection using this polygon. Now this is what we call in the world of GIS spatial intersection. So what I see now, what I'm left with, is only the sub-suppliers that fall within this area. We can now see that only 3 farmers are found within a 1 hour drive, which represents a coverage of 22%. This is probably why this supplier has a longer delivery time. Now this was an example of how using GeoQlik we can identify an anomaly on a global level and then drill down in order to study it locally. We talked a lot about the supply chain. Let's move on to the fun stuff, weather data. What we see here is a GeoQlik map presenting a precipitation forecast. A few words about this data. I grabbed it from an online service of the NOAA, again the National Oceanic and Atmospheric Administration in the US. What we actually have here is a period of 1 month, where for each day we display the precipitation forecast for 7 days later. So right now, looking at the forecast for March 4th, originally published on February 26th. With the slider at the bottom, I can choose the day to display, or simply click the play button to see an animation. Blue is rain, yellow is very low probability of rain, and green is somewhere in the middle. Also, note that the shapes are different from one day to another. So this looks like a typical weather forecast you'll see on TV. We've seen that, which is pretty cool, but it isn't enough to help me better predict the demand for my products in the different stores. So let's move on to the next sheet to see how all this can be linked to my business. And so what we've got now is the same precipitation data, but this time integrated into my business territory. I've obtained this through spatial transformation of the raw data, which allowed me to project it into the counties of the US. All this geographic data is stored in a spatial database, which is the proper way to handle such data. GeoQlik connects directly to this spatial database, so no need to have this data in my business model. In other words, GeoQlik serves as a bridge between Qlik Sense and the world of GIS. Here too, I have a month of data that I can visualize with an animation. And so 1 month of precipitation data but this time projected onto the counties of the US. The next step is going to be to project all of this on my supply chain. And so moving on to the next sheet. This sheet allows me to see how the precipitation model impacts my business. Before using this tool, the demand of the stores was determined based on statistical data. After applying this model, I can adjust the demand based on the weather. And with the definition of my supply chain, I can translate this demand to the volume my factories need to produce. Let's look at the factories. This is what we're seeing right now on the map. The size of the bubbles describes the volume they need to produce for each day. Let's do the same thing. Let's activate the animation. You can notice now that whenever a blue zone hits the bubbles, they become significantly smaller. So when it rains near our stores, we need to produce less, knowing that we predict the consumption 7 days in advance. What we can do now is also bring in the other elements of the supply chain. And so displaying also the suppliers and the stores. And of course, viewing the links between the different elements. Suppliers to the factories, factories to the stores. Let's focus on a particular case. So let's take this cycle here and zoom on it. We can even display the volumes over the objects. So the volumes the supplier needs to handle, the factories, and the stores. Let's maybe remove the weather layer. Doesn't interest us anymore. And change to a different base map that allows us to have a better contrast. And we can also play the animation again to see how these figures change day after day. And so we have 3 suppliers at the bottom, evenly sharing the volume they deliver to a single factory. The products then arrive to 2 different shops. The idea with all of that, again, is to be able to better predict the demand and adjust our production volumes accordingly. This also helps me negotiate with the supermarkets because I can better guarantee that they're buying what they need. Not more, not less. I will conclude the demonstration with this sheet. Fresh and Ready adopted this tool in 2016. At the end of the year, they will want to measure the total savings obtained in terms of overproduction and underproduction. On the left, we show the overproduction at the top and the underproduction at the bottom. We need 2 separate graphs since we're measuring the overproduction and underproduction separately every day. We analyzed both these elements throughout 2015 2016, the year in which we adopted this tool, and we include a forecast for 2017. The bars shows me how much we overproduced and underproduced, and the graph in red shows how much we saved in total. Using GeoQlik, we can project this information on the different factories. The figures show us how much in total we saved in 2016 compared to 2015, which allows us to notice that we generally made significant savings, except for two places, here in Oklahoma and in North Carolina. Now, that can be for many different reasons. Additional factors probably need to be taken into account. Maybe integrate demographic data. Let's focus on one area, maybe North Carolina, and zoom in to see more information. We now see that with zooming in, I now get bar charts over the different factories. The bars show me the underproduction and overproduction for 2015 and 2016 for each one of the factories. First two bars for 2015 and then two for 2016. And this allows us to see that our biggest problem in North Carolina is underproduction. And back to my presentation to conclude. We've seen that GeoQlik integrates perfectly within a Qlik Sense dashboard. Configuring it and using it are easy and intuitive, following the Qlik Sense philosophy. Selections also work in the exact same way. We can have several layers in the same map, and we can also mix different levels of detail, different dimensions that show up together on the same map. Using a single analysis, we can display several different indicators: the size, the color, the opacity, the label, the tooltip. Each one uses a completely different expression. And with different visualization types, we can provide different types of insights that help us uncover hidden phenomena. All of these tools are essential in a complete mapping solution. GeoQlik brings some advanced GIS tools into Qlik Sense. Something we haven't seen is the GeoQlik Management Console. It is a centralized asset management system for geographic data. It allows me to connect to external geographic data coming from different types of sources, either files or spatial databases. These resources can then be shared by all of the GeoQlik users within my organization. Spatial databases, by the way, are necessary when dealing with larger volumes of geographic data. Such data needs to be used with proper spatial indexing. GeoQlik can plot areas based on actual driving times. As we've seen, this can then be used to create a selection. And last but not least, GeoQlik is fully compatible with mobile devices. Before I end, I'd like to say a few words about the company behind GeoQlik. We're called Business Geographic, and we've been Qlik's first technology partner. So we've been here for a while. We're a software company specializing in GIS and location analytics. We develop advanced mapping solutions for public or private entities. We also provide a platform of geoservices, such as address geocoding, drive time areas, or route optimization. Using this platform, you can perform different types of calculations in a batch mode. And last, but certainly not least, please note that we also have a version of GeoQlik for QlikView 11 and 12. Thank you very much for your attention.